Have you ever wondered why an LED bulb suddenly stops working even though most of the LEDs inside still look perfectly fine? Today we're going to track down the real problem using nothing more than a battery and a safety pin. Hey everyone, I'm Dan. Welcome back to Dan Fix. Before opening the bulb, I want to make sure the problem is actually inside the bulb itself and not coming from the socket. So I grab another LED bulb that's still working normally and test it in the same socket first. The light turns on immediately. That confirms the socket is perfectly fine. Using a utility knife, I carefully slide the blade into the small gap around the plastic cover. Slow pressure, gentle twisting motions. The adhesive seal slowly begins separating from the housing. LED bulbs are usually glued tightly to prevent dust and moisture from getting inside, so forcing them open too quickly can easily crack the plastic cover. After working around the edge little by little, the diffuser cap finally lifts away. Now we can see the LED board underneath. Now the board needs to be disconnected from the bulb base. Using pliers, I cut the wires as close to the LED board as possible. The reason is simple. Longer wires make reconnecting everything later much easier and safer. Now comes the interesting part of this repair. We're going to build a very small LED testing tool using a safety pin. First, I remove the locking section from the safety pin so only the straight metal section remains. Then both ends get sharpened carefully using sandpaper. Small grinding motions back and forth. The metal slowly becomes sharper and thinner at both tips. These sharp points will help touch the tiny LED contacts more accurately later. After sharpening is complete, the safety pin gets cut into two equal metal probes. Now I prepare a 9-volt battery connector wire. Now each sharpened metal probe is attached to one wire end. The thin copper strands wrap tightly around the small metal pieces while the connection is pressed firmly together. At this stage, the tool still looks very simple, but it's already capable of testing individual LEDs directly from a small battery. Next, I prepare two heat shrink tubes. These small tubes may not look important, but they actually protect the electrical connections from touching each other accidentally. Without insulation exposed, metal can create short circuits very easily during testing. Now the heat shrink tubing slides over the metal connections. Then gentle heat is applied slowly. The tubing begins shrinking tightly around the wires and metal probes. Everything suddenly feels much stronger and cleaner afterward. Now the 9-volt battery is connected to the battery clip. And just like that, our homemade LED testing tool is complete. The principle is actually very simple. The battery provides a small amount of voltage, while the two metal probes deliver current directly to each LED chip individually. If the LED still works, it lights up immediately. If it stays dark, that LED is likely damaged. And this matters because most LED bulbs use a series circuit. That means a single failed LED can interrupt the entire electrical path and shut down the whole bulb even when most of the LEDs still look perfectly normal. The solder slowly begins softening underneath the chip, and using tweezers, the damaged LED is lifted away carefully little by little. Slow movements matter here because overheating the board can damage the copper traces underneath. Now we need a replacement LED. So I grab another damaged LED board and begin testing its LEDs using the same homemade tool. One by one again, most are dead. But eventually one LED lights up brightly. That's the replacement we need. By the way, where are you watching from today? And have any of you repaired LED bulbs before instead of throwing them away? I always enjoy learning repair ideas and workshop tricks from people around the world. So leave your experience in the comments below. Now the working LED is heated carefully and removed from the donor board. Then the replacement chip is positioned slowly onto the original LED board. Alignment matters here because reversing polarity can prevent the LED from working properly. Once the solder melts again, the replacement LED settles into place. Before reassembly, the board gets cleaned thoroughly. Dust, leftover flux, and loose debris are wiped away carefully because even small contamination can trap heat over time. Now the original wires are stripped again slightly to expose fresh copper underneath. The wires reconnect back onto the LED board one by one. Slow twisting motions, firm electrical contact, everything secured carefully. One tiny failed LED caused the entire bulb to stop working. But with a few simple tools and a little patience, the whole bulb can be brought back to life instead of being thrown away. Now the plastic cover gets sealed back into place with silicone glue. And just like that, this household bulb is ready to be used again. Repairs like this may look small, but over time they can save a surprising amount of money while also helping us understand how everyday electronics actually work. If you enjoyed this repair project, don't forget to like and subscribe because there are still many more useful DIY ideas coming soon. Thanks for watching, and I'll see you in the next video.